Hello, today's notes, we are talking about volume. So what is volume? Volume is going to be the measure of space a three-dimensional shape takes up, okay? So measure of space a figure occupies. It's a good word, occupies. So we have two postulates to get us started. Our first one is the volume of a cube. The volume of a cube is the length of its sides cubed. Okay, so by cube we mean a prism where all the sides are squares. So each side is a congruent square. Okay, and you may have heard that the volume of a box is length times width times height. Okay, so if I have a box here and I have the length, the width, and the height, the volume is length times width times height. But if all three of those are the same measure, like it would be in a cube, then it's just that length cubed. Our next postulate is the volume addition postulate, and it says the volume of a solid is the sum of the volumes of all of its non-overlapping parts. Okay, that makes sense. All right, here's an example where we put those two together. Find the volume of the puzzle piece in cubic units. Okay, so over here it discusses 1 cubic unit is 1 by 1 by 1. And so now I have this piece, this puzzle piece over here. So if I look at the base layer, let's just look at the base layer. So just the bottom down here, I can see that it's 7 cubes by 2 cubes. So that base layer down here is going to be 14 cubes. Okay, so my base layer is 14 cubes. Okay, 2 by 7. And then if I look at the top left over here, look at this piece over here, I get 2 by 2. So top left layer is going to give me 4 cubes. And then if I look over here, the top right, I have 1 by 2. So the top right is going to give me 2 cubes. So if I add that all up, I get a total of 20 cubes. Okay, or I can say 20 units cubed. Or 20 cubic, that's what I'll do, 20 cubic units. Okay, which is the same thing as 20 units cubed. Doesn't matter how you write it. Okay, so, but what if each of those cubes wasn't 1 by 1? Let's talk about that real quick. So what if my cube was, let's say it was 2 by 2 by 2. Okay, so 2, 2, 2. Then 1 cube would have a volume of 8 units cubed. Okay, so 1 cube or 1 cube block, let's call it 1 cube block, okay, would have 8 cubic units as its volume. So then when I would figure out that I have 20 cubes, I would multiply that 20 by 8. Okay, but yep, our answer is just 20. Okay, next two theorems. We have the volume of a prism and the volume of a cylinder. So the volume of a prism is base times the height, or the area of the base times the height. And the cylinder is the same thing. So a cylinder is the volume of the base times the height, or the area of the base times the height. And the area for our first one, so let's look at this. So the prism they give us for this picture is a box and a rectangular prism. And so if I have volume equals the area of the base times the height, well, the area of that base is going to be the area of that rectangle, which we know would be length times width. So I get length times width times h. So that works when it's a rectangular prism, okay? And so that goes back to talking about that box in the first example when we talked about cubes, okay? Our next one, cylinder. Well, the area of the base here is a circle. So that's why we have two formulas here, because the area of a circle formula is pi r squared. Okay, but they essentially are the same formula. Volume equals area of the base times the height. Okay, so let's do an example. So here we have a trapezoidal prism. So I need to find the area of the base, which is a trapezoid. So if I look at this trapezoid, it tells me that I have one length of the parallel sides is 14. The other length of parallel side is 6. And the height of that trapezoid, not of the prism, but of the trapezoid, is 3 centimeters. So the area of my trapezoid is going to be 1/2 times the sum of the bases of the trapezoid. Remember, so the bases are the parallel sides. So I'm finding the average of the parallel sides times the height of the trapezoid, which was 3. So I get 1/2 times 20, which gives me 10 times 3 is 30. So I have 30 centimeters squared is the area of that. So then when I want to find the volume is the area of that base times the height of my prism. So the area of the base we just found was 30, and the height of the prism was 5. So my volume is 150, and this is going to be centimeters cubed because I'm in 3 dimensions. Okay. The next thing we're going to talk about is Cavalieri's principle. So Cavalieri's principle says if two solids have the same height and the same cross-sectional area at every level, then they have the same volume. Okay, so these two figures here that are both the first two here, those two are going to have the same rectangular. Oh well, I guess not, because one of them's a rhombus and one of them's a square. But if this was congruent, if the bases here were congruent, if this shape and this shape were congruent, maybe they are, I can't tell, then those two prisms would have the same volume. Okay, here's an idea with quarters. So if I have quarters, you can think about it as each quarter is the cross section, and I can have a right cylinder. Okay, so this would be a right cylinder, and I am occupying the same amount of space as if I wobbled those quarters around, right? Each quarter takes up the same amount of space. It's the same amount of quarters, but now my shape is not right. It's not easy, but I know that the cross sections are the same throughout, so it's going to take up the same amount of volume. Okay, so let's look at an oblique cylinder using that concept. So find the volume of the oblique cylinder. Okay, so remember our volume formula is the area of the base times the height, and the area of the base is going to be the area of this circle here. So the area of that base is going to be pi r squared, and r is 4. So it's going to be 16 pi. Okay, so I'm going to plug that in. So now my volume is 16 pi times, and then the height of this oblique cylinder is 7. So then I'm going to get that I have the volume is 112 pi. So that's my exact answer before I plug it into my calculator here. And on my handy dandy calculator, I find that that is approximately 351.86 centimeters cubed. Okay, we have two more formulas, volume of a pyramid and volume of a cone. And these two are also the same. Okay, so the basic idea here is that the volume of a pyramid or the volume of a cone, instead of just the area of the base times the height, we have to account for it getting smaller along the way, and that smallness is a third. Okay, so the volume of a pyramid is 1/3 times the area of the base times the height, which is also the same for the volume of a cone, but we know that the area of the base of a cone is pi r squared. Okay, so that's where that comes from. Okay, so there's our pictures, there's our formulas. Let's take a look. So next, let's find the volume of this solid. So this looks like an oblique cone. So we're going to use our volume of the cone formula, which says that the volume of the cone is 1/3 times the area of the base times the height. And my area of the base formula is pi r squared since it's a circle. So my volume equals 1/3 times pi, and then 2.2 squared times, and then the height of this oblique cylinder is 4.5. So I can just plug that whole mess into my calculator, and I'm going to get, well, before I multiply by the pi, if we want, we would get it's approximately, well, let's not do that. Let's just plug it all into our calculator, because 1/3 is not very friendly. Okay, so if I plug it all into my calculator, I'm going to get it's approximately 22.81 cubic centimeters. Fantastic. Next example. Originally, the pyramid picture had a height of 144 meters and a volume of 2,226,450 cubic meters. Find the side length of the square base. Okay, so that's good. They tell me the square base. So I know that the volume equals 1/3 area of the base times the height. Okay, so let's fill in our pieces here. Originally, the pyramid picture had a height of 144 meters. Okay, so that's this. And a volume of 2 million some odd stuff. Okay, so if I put in my 2 million over here, equals 1/3 times the area of the base times my height was 144. Okay, fantastic. So now let's go ahead and multiply by 3 to get rid of that third. So I'm going to multiply both sides by 3, and that cancels with a third. And so now I get 6,679,350 equals 144 times the area of the base. So divide by 144. And I have that the area of the base is 46,384 approximately. And then what I'm going to do is they tell us that the base is a square. Okay, so if my base is a square, that means that if I want to call just one of those sides x, that's what we can do. So our base is, area of the base is going to be x squared. So if I take the square root of that, that's going to give me x. So the length is approximately 215, and what are my units here? Meters. Okay, so that's going to be the length of that base. Okay, next, find the volume of the right cone. Okay, so back to our good old volume formula for cones and pyramids, remember, is 1/3 times the area of the base times the height. Okay, so let's look at this. Oh no, they don't give us the radius. Uh-oh. Okay, let's see here. Let's see what we got to do. So if I look at this, they give me this length here, and they give me that the angle between my lateral side and my radius is 65 degrees. So I get a nice little right triangle. So I have 65 degrees. I have a length here. I want the radius, and I know the height is 16 feet. Okay, so we can use our friend trig. Yes, our good old trig ratios. So if I look at this, here's my angle of measure is at 65 degrees, and the 16 is going to be the side opposite of that. And I want the radius, which is the adjacent side. So I'm going to use the tangent ratio. So the tangent of 65 degrees equals opposite 16 over adjacent r. So if I solve for r, I'm going to multiply by both sides by r to get rid of my fraction. So then I get r times the tangent of 65 equals 16. Then I'm going to divide both sides by the tangent of 65. So I get that the radius equals 16 divided by the tangent of 65 degrees. And so then I'm just going to plug that into my calculator. So I'm going to do 16 divided by, and then parentheses, tangent of 65 degrees. And I'm going to find that the radius is approximately 7.46, and my units here are feet. Okay, so now if I go back to my volume formula, I can find that the area of the base is pi r squared, and r is 7.46 squared, times the height of my cone is 16. And so when I plug that into my calculator, I'm going to get approximately 932.45 cubic feet. So that would be my answer for the volume of that cone. Okay, lots of examples today. So go ahead, try your homework, find volume of all those figures.